Hey, what's up? Welcome back. Patrick here. Moving on to the next example in the midterm review. So we got a word problem here. Two parts to it. So number one, we're told if the radius of a circle increases by 60%, by what percent does the circumference increase? And part B, the area increase. And then in part two, we're told if the radius of a cylinder increases by 50% and the height decreases by 20%, by what percent does the volume change? All right, so starting with number one here. Now, let's say we have this original circle and we just label the radius as r, like that, right? Just a regular circle. We know the circumference of this circle is going to be what? 2 pi r, and the area is going to be pi r squared, like that. That's going to be the circumference and the area of the original circle if we let the radius be r. Now, if we increase the radius by 60%, right, so we're going to have this new circle over here. Question is, what's going to be the expression for the new radius? Well, if we take anything and increase it by a certain percentage, we're going to multiply it by 1 plus r. And r is going to be that percentage, but in decimals. So we're going to multiply it, in this case, by 1 plus 0.6. By the way, this r here and this r, they're not the same, right? This represents the rate of change. I should have maybe used a different variable here, while this r represents the radius. I just realized that they were the same variable, and I don't want you getting confused there, right? This represents the rate of change, right? And it's changing by 60%, so this would be 0.6, which means this would end up being 1.6, right, if we simplify this bracket. And so we're basically going to take this r value here, this original r value, this radius, and multiply it by 1.6 to get the new radius like that. That's going to be the expression for this new radius, 1.6 r. And so now what we have to do is see, okay, by how much did the circumference increase? Well, we know that the circumference is equal to 2 pi times the radius, right? 2 pi times whatever the radius of the circle is. Well, in this case, our radius is 1.6 r, like that. Okay, but what we have to do is see how much did this original circumference 2 pi r increase by. Well, notice we could just bring the 1.6 in front, like that, and then we'll have 2 pi r over here, the original circumference. So basically the original circumference, 2 pi r, it also increased by 60% because it's a linear function basically, right? 2 pi times the r value, there's no like square there or anything. You're going to see with the area, it's not just going to increase by the same amount, but because the circumference is a linear function, if you increase the radius by a certain percentage, so in this case by 60%, it means the circumference is also going to increase by that same percentage, which is in this case 60%. So the circumference increased by 60% because we're taking the original circumference and multiplying it by 1.6, right? And so it's basically increasing by 60%. Now, what about the area? Well, again, we know area, it's equal to pi times the radius squared. Well, in this case, our new radius is 1.6 r, and we have to square that entire expression in brackets. And so we're basically going to have, if we simplify this, 1.6 squared times r squared, like that. And so from here, let's actually continue this up here. So we'll have the area is basically equal to pi. Now 1.6 squared, that gives us 2.56, and then we just have the r squared floating around right there at the end. Now we want to see, what did we take this original area by, or what did we take this original area and multiply it by? So I'm going to bring the 2.56 in front, and then I'm going to put the pi r squared together over here. So notice that we took this original pi r squared area and we're multiplying it by 2.56, right? So we're increasing the area by a factor of 2.56. But you got to be careful because they're asking by what percentage does the area increase. And if you remember, let's do this in a different color here. So how we get basically this factor that we're going to multiply, that's equal to 1 plus r, right? Remember that factor that we got here when we increased the radius by 60%? We plugged in 0.6 here to get a factor of 1.6. Okay, so now we're going backwards. We're given this factor, 2.56. And again, you know what? I'm not going to use r here. Let's just use like a different variable. Let's use m, just so you're not getting confused thinking that it's the radius, right? This m represents the percentage change, right? So before the factor that we got was 1.6, we got the percentage, plugged it into this 1 plus m, 1 plus 0.6 to get a factor of 1.6. Well, now we're going backwards. We're given the factor of 2.56. So we know that 1 plus m is equal to 2.56, and we have to solve for the m value, and that's going to be the percent change. So we bring the 1 over, and that's going to be 2.56 minus 1, which is 1.56, but this is in decimals. Remember, that's not percentages yet, so we have to multiply this by 100 to get 156%, right? So the area increase was 156%, right? So we multiplied the area by 2.56, so we more than doubled it. But when we talk about the actual percentage increase, right, this 2.56 is equal to this 1 plus the percentage increase, right? And that's going to be in decimals, so we have to multiply it by 100 after to get the 156%, right? If something doubles, like if you multiply something by 2, it's increasing by 100%, right? Because that factor of 2 that you're multiplying the original quantity by, that's equal to that 1 plus m, that percentage change. So m is going to be 2 minus 1, which is 1, but this is in decimals, so you got to multiply that by 100 to get 100%. So if something doubles, right, if the factor is 2, then you're increasing that thing by 100% if you're talking in percentage terms, right? So just be careful with that. It's not going to be increasing by 256% is what I'm trying to say, right? If you're multiplying something by 2.56, it's increasing by 156%. Moving on to part 2. So here we're told if the radius of a cylinder increases by 50% and the height decreases by 20%, by what percent does the volume change? So let's do the same thing. Now with a cylinder, there's actually 2 dimensions, right? There's the radius and the height that we have to look at versus a circle. It's just the radius that's important. Well, here, a cylinder is a 3D shape, right? So there is multiple dimensions to take into account. So let's say that we have a radius r, and then there's the height of the cylinder, which is h, like that, right? So this is our original cylinder. And if a cylinder has a radius of r and a height of h, the volume expression for it is pi r squared h, like that, right? So that's going to be the volume of our original cylinder. Okay, so now what we're told is that the radius of the cylinder is going to increase by 50%, but the height's going to decrease by 20%. Okay, so we're going to have a larger radius and a smaller height. So what's going to be the new expressions for the new radius and the new height? Well, if we're taking our radius, our original radius r, and we are increasing it by 50%, it's always 1 plus the percentage change, but that percentage change has to be in decimals. So we would take the 50, divide it by 100, which would give us 0.5. So we're taking our original radius, multiplying it by 1.5. So it's 1.5 r. Okay, so if we have a radius of r and we increase it by 50%, we're multiplying it by 1.5. All right, so that's going to be the new radius there. Now, what about the height? Notice the height is decreasing by 20%. So we're going to take our original height, and we're going to have 1 instead of plus, instead of increasing by a certain percentage, we're going to be decreasing it by 20%. And the 20% we have to convert to a decimal. 20 divided by 100 is 0.2, like that. And so we're going to take our height and multiply it by 0.8. So our new height is going to be 0.8 h. Like that, right? So if we decrease something by 20%, it's like taking the original quantity and multiplying it by 0.8. Okay, so it's a little counterintuitive. Decreasing something by 20% is like multiplying it by 0.8, right? Because we're going to still have 80% of the original value if we decrease it by 20%. Where this 0.8 comes from is from this bracket when we do 1 minus 0.2. Right, so that's going to be the dimensions of our new cylinder. So now let's take this new cylinder and let's find an expression for the volume. So the volume of a cylinder, it's pi times whatever the radius is squared. So our new radius is 1.5 r. That's going to be squared. And our new height is going to be 0.8 h, like that. Okay, and let's simplify this. Let's see what happens. So this squared, because there's this bracket here, we got to take everything inside that bracket to that exponent. And then nothing we can do here. So let's keep it as 0.8 h. Now this 1.5 squared, that's going to be 2.25. That's going to be r squared. Then we'll have still 0.8 h. So what I'm going to do, because we want to see how much did we multiply this volume by. So this pi, r squared, and h, I'm going to put at the end. And then this 2.25 and 0.8, I'm going to multiply together. 2.25 times 0.8 gives us 1.8. And then we have the pi r squared h. And notice that the pi r squared h, that's our original volume here. And so we took our original volume and we're multiplying it by this factor 1.8, right? So remember, it's always 1 plus whatever the percentage change is equal to the factor you're multiplying, 1.8. Bring the 1 over, 1.8 minus 1 is 0.8. Multiply this by 100, we get 80%. So that is the answer right there. By what percent does the volume change? It's increasing by 80%, right? Because we're multiplying it by 1.8. If you multiply something by 1.8, you're increasing that original quantity by 80%, right? So first we have to find the expressions here in terms of the new height, the new radius, and then you plug it into the volume formula and find out whatever that factor is at the beginning of which you're multiplying the original volume by. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.